All right, 4.5, we get into a couple other ways to prove triangles are congruent. So our question is, how do you prove triangles are congruent if you only have one pair of congruent sides? Okay, so one of the definitions is an organized visual representation that uses arrows to show the flow of a proof. So a flow proof is a little different than a two-column proof. All right, so what we got is angle side angle congruence. So it's kind of like side 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 and side angle side, except for now we have letters in different orders. So angle side angle is ASA. So if the two triangles are congruent, then angle A is congruent to angle D. Side AC is congruent to segment DF. And angle C is congruent to angle F. So we have angle, side, angle. And we would say triangle ABC is congruent to triangle DEF. So we can prove triangles are congruent if we only know one of the sides. There's also angle side. So notice in the first one that that blue side was in between the two angles. Over here, we have a pair of red angles, a pair of green angles, and this time that blue side is not in between them. It's not in between the two angles that are congruent. So angle A congruent to angle D, angle C congruent to angle F, and side of segment BC congruent to segment EF. So again, triangle ABC is congruent to triangle DEF, but this time we showed it by doing angle side and not angle side angle. So these are two new ways to show triangles are congruent. Okay, so example 1. Can the triangles be proven congruent with the information given in the diagram? If so, state the postulative theorem. So off to the side, what we knew before was side, 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 and hypotenuse leg. Now we just added angle, side, angle, and angle, side. So let's check to see which one of these would show the triangles are congruent if they're congruent. So if you look at this picture, we have two angles congruent already. And in the picture, is there anything else we can say about it that's congruent? So what we have is actually vertical angles. But is there anything we know about the sides that could show us the sides are congruent? And the answer to that question is no. We cannot show the sides are congruent. So what we have here is like we have angle. Actually, we have angle. But none of those are what we want. We don't have any of these possibilities. So can the triangles be proven congruent? No. Not sure, or not sure if congruent. Okay, we don't know for sure they might be, but we can't say it based on the information given. The middle one, we have two angles, right? We have angle. Right, we have the blue angles and these red angles that are congruent. What we also have is they share a side. This would be a side. So you see how that side's not in between them? If you go around the triangle, it's angle, side. Angle, side. So are these congruent? Yes. Angle, side. Okay, and then the last one. In the picture, we have an angle, and we have a side. So we're looking for, is there another side or another angle that's congruent? And in this picture, we have vertical angles. So this would be another angle. So if you look, we have angle, side, angle. And In this case, the side is in between the two angles. It's included. So that's why it's angle, side angle, and not angle, angle, side. That looks like bad writing, so let's rewrite it. Angle, side, angle, congruence. All right, so the checkpoint, same thing. Can you prove that triangle STW and triangle VWT are congruent with the information given? If so, state the postulate or theorem. So STW, I'm going to highlight this. S to T to W is that red triangle. I'm going to redraw it. Okay, and then we have this blue triangle I'm going to highlight. VWT. So we have 60 degrees again. Okay, so if we look at this right now, what we have is one pair of angles that are 60 degrees. And then we have one pair of 90-degree angles. Right, so we have angle, angle. Is there anything else in the picture that is the same? And if you look, do you see up here that this red and blue lines are overlapping? That's because TW is in both triangles. So TW is congruent in the two triangles. So what we actually have right now is we have angle, angle, side. So are these triangles congruent? Yes. Angle, angle, side congruence. Okay, and number 2, same thing, let's check. Now notice that these two, we have a right angle. So we got angle, angle. We have another angle. And now these aren't even, they're not like intertwined, but they are touching. So do you see that this side right here, side TW, is the same in both of them? So in this shape, these two triangles, we have angle, side, angle congruence. Okay, because notice that that green line is the same line in both triangles, which gives us angle, side, angle. All right, so let's slide down to the next example. This example, we're going to do a flow proof. So in the flow proof, we start with the given. So if we look at the diagram, we have, they tell us angle 1 congruent to angle 4. Okay, this is given. We also know that CF bisects angle ACE. This is also given. So I'm going to mark this in the picture. Angle 1 congruent to angle 4. And CF bisects angle ACE. CF bisects the big angle ACE. And we're trying to show that triangle CBF, so this triangle right here, and triangle CDF, so CDF, are congruent. Okay, so since CF bisects angle ACE, I'm going to call this angle 5 and 6 to make it easier. So we're going to say here, if I draw an arrow, since CF bisects angle AC, we know that angle 5 is congruent to angle 6. Definition bisects. Okay, so we have congruent angles in each. We have one pair of congruent angles. Okay, since angle 1 is congruent to angle 4, our next statement's going to be measure of angle 1 plus measure of angle 2 equals 180, and measure of angle 3 plus measure of angle 4 equals 180. Okay, and the reason why we know that is if you look, 1 and 2 form a line together, and 3 and 4 also form a line together. So they're supplementary to each other. So based on this, since 1 plus 2 is 180, and 3 plus 4 is 180, we can justify and say that measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 4. And it's because they both equal 180. So then, drawing another arrow, we said 1 and 4 are congruent. So if we subtract 1 and 4, because they're the same and they cancel out, we would say measure of angle 2 must be equal to measure of angle 3. Okay, so we know that 2 and 3 are congruent. So we have two angles. Let me get my eraser out and see if this works. I'll redraw this. So we have two triangles, the blue one and the green one. And we have two pairs of angles that are congruent. And then last thing we're going to say is this side right here, CF, is equal to itself. CF is in both triangles. So that will be a side that's congruent. So I'm going to say CF equals CF. So now because of this, we have angle, angle, side. So now we can say the triangles are congruent by angle, angle, side. So triangle CBF is congruent to triangle CDF by angle, angle, side. So that's kind of how a flow proof works. We won't be doing a ton of them, but it just kind of works through like, what can I say next? And then we can see the lines drawn that show angle, angle, side congruence. We're going to skip the checkpoint because it's really the same as example 2. And we're going to slide down to, actually, that's it. We're going to skip the second checkpoint. We're only doing one flow proof, and that's all we got.